Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 6 on seeing structure in expressions. Before we kind of get into this, what we're going to do is we're going to talk about what I call mindful manipulation of algebraic expressions. So let's take a look at what that is. All right. In algebra, students oftentimes think that they're just memorizing a bunch of procedures on how to solve an equation, how to do this thing or that thing. But most of the time what we want you to do is mindfully manipulate expressions. And all a mindful manipulation is an algebraic technique that's applied with a purpose in mind, something that you're aiming for. And even if we're unsure if the manipulation will result in success, in this sense we want to give ourselves permission to do manipulations even if they fail to reach our purpose, whatever that purpose is, solving an equation, writing an equivalent expression, what have you. So in this lesson, we're really just devoting ourselves to learning how to do mindful manipulations and seeing structure in an expression, right? In the way that it's written, in the way it's algebraically laid out. So let's take a look at exercise number 1. Let's see what we've got. Consider the expressions 2x plus 1 and 6x plus 3. Letter A, evaluate both expressions for the two values of x shown below. All right, so let's talk about this a little bit, right? I've got these two expressions, 2x plus 1 and 6x plus 3, and I want to just see how they relate to each other. Obviously, they're not equivalent expressions, right? There's just no way. But what we're going to do is we're going to take values of x like x equals 2 and x equals 5, and we're going to substitute them into the two expressions to see if we can somehow come up with some kind of a relationship between them. So let's do x equals 2 together, and then I'm going to have you do x equals 5 on your own. Let's go to the board. All right, so here we go. X equals 2. For 2x plus 1, I'm going to substitute 2 in for x. Remember, order of operations says we have to do that multiplication first, and then we do the addition, so I just get 5. On the other hand, for the expression 6x plus 3, I'll get 6 times 2 plus 3. That'll be 12 plus 3, and that'll be 15, right? That right away would be enough to tell us that the two expressions aren't equivalent because they have different values for the same value of x. What I'd like you to do now is pause the video and see what those two expressions are equal to when x is equal to 5. Take a couple minutes. All right, let's do it. Here we go, back to the board. For 2x plus 1, I've got 2 times 5. Make that maybe look a little more like a 5. 2 times 5 is 10. 10 plus 1 gives me 11. All right, for 6x plus 3, we've got 6 times 5 plus 3. That's going to be 30 plus 3, and that's going to be 33. All right, so again, obviously not equivalent expressions. 5, 15, 11, 33. But there is a relationship between the two expressions, and let's take a look at letter B to think about it a little bit. What is the ratio of the larger outcome to the smaller? In other words, divide the larger by the smaller in each case. How can we use the distributive property to show that this ratio will always be the same number? All right, well, simple enough. Let's talk about that ratio, right? In the first case, the ratio of the larger to the smaller, 15 divided by 5 is equal to 3. And in the second case, we've got 33 divided by 11, and that's also equal to 3. So in both cases, the ratio is equal to 3. The question is, well, why is that? And how can the distributive property tell us that we could pick any value of x we wanted, and what we would always find is that the value of 6x plus 3 would always be 3 times the value of 2x plus 1? Well, we can do it in two ways. We can either use the distributive property sort of in the forward direction when we multiply a binomial by some constant, or we can use it in the reverse direction when we do the factoring. And that's kind of the way that I'd like to look at it. So if we go to the board, right, I could write down 6x plus 3, and I could think to myself, well, 6 is 3 times 2, and then I've got my x coming along for the ride, and 3 is 3 times 1. So I can see that common factor of 3, and I can say, 6x plus 3 is just 3 times 2x plus 1. And there it is, right? The relationship of this expression and this expression the two expressions that I looked at, is simply that 6x plus 3 will always be 3 times the value of 2x plus 1. I can see that experimentally, right, when I substitute numbers for x, and then I can see it using the distributive property here. Let's keep working with a little bit more in terms of mindful manipulation. We want to continue to manipulate expressions in mindful ways and use the structure of an expression to understand its behavior. All right? In the last case, we used the distributive property to understand why one expression was always going to be 3 times the value of another. Let's get another property involved in exercise number 2. Consider the expressions 3x plus 2 and 3x plus 7. Letter A. Evaluate both expressions for the two values of x shown below. All right, well, we've already played this game once in exercise number 1. I'd like you to pause the video now and actually evaluate 4 times, right? Twice for x equals 3, twice for x equals 7. Evaluate both expressions, and then we'll come back and go through them. Take a minute. All right, let's do it. So for x equals 3, we've got 3x plus 2, so that's going to be 3 times 3 plus 2. 3 times 3 is 9, and 9 plus 2 is 11. On the other hand, 3x plus 7 is going to be 3 times 3 plus 7. That's going to be 9 plus 7. Oh, almost fit. And that's going to be 16. All right, obviously not equivalent. For x equals 7, we'll have 3 times 7 plus 2. 21 plus 2, and that's going to be 23. And 3x plus 7 here, it's going to be 3 times 7 plus 7. It's going to be 21 plus 7, and that's going to be 28. All right. Here the relationship really isn't about ratios, right? It's not like 16 is 3 times 11 or 28 is 3 times 23. What is the relationship? Well, let's take a look at letter B. How much greater is the second expression than the first expression in each case? Show why this is true by using the associative property of addition, the associative property of addition. All right, so I'm claiming that 3x plus 7 will always be a certain amount larger than 3x plus 2, and it doesn't matter what value of x you pick. All right, and what is that difference? Well, it's pretty easy to see. Let me bring this down a little bit, right? In the first case, the difference is 5, and in the second case, the difference is also 5. Now, why is the difference always 5? Well, we can think about the expression 3x plus 7, and we kind of want to compare it to the expression 3x plus 2, right? It may be pretty obvious why this expression is always 5 units greater than this one. But let's mindfully manipulate this one a little bit better so that we can see this expression kind of hiding out within this one, right? And I'm just going to work on the 7 given that they both have a term of 3x in them. It's all about the 7 versus the 2. Well, 3x plus 7 is the same as 3x plus 2 plus 5. Right? Obviously 7 is the same as 2 plus 5. But now we have this thing called the associative property of addition, which says if I'm adding 3 things, 3x, 2, and 5, I can regroup those so that I'm adding the first 2 first instead of the second 2. And there we have it, right? There's our expression 3x plus 7. There's our expression 3x plus 2, and we can see that 3x plus 7 will always be 5 more than 3x plus 2. It doesn't matter what you put in. And it's very important that we look at something like 3x plus 7 and 3x plus 2 as single things, right? 3x plus 2 is a quantity. That quantity depends on x, right? But we look at it as a single thing, and this thing will always be this thing plus an additional 5. All right. Now we get into the fun. Now we're going to kind of play around with some different things so that we can really bring out structure. It's important to be able to view parts of an expression as a single entity when necessary. This skill arises in many different areas of algebra, so we want to sort of lay the basis early on in this course so that you start seeing these multiple parts of an expression as a single thing. So let's do it. Exercise number 3, if I can get this thing to come down. Apparently I can't. Oh, there it goes. Little lag on my board here. Exercise number 3. The expression 3x plus 2 is equal to 7 for some value of x. Don't solve for it. We could solve for it, but it would be an ugly value of x, and that's not the point. So 3x plus 2 is equal to 7 for some value of x. Determine the values of each of the following expressions for the same value of x. Show your manipulations. All right, in other words, I want to take the expression 9x plus 6, and I want to think about how it relates to 3x plus 2. How does 9x plus 6 relate to 3x plus 2? Well, hopefully when you're thinking about 9x plus 6 compared to, I'll put versus 3x plus 2, obviously, or hopefully it's pretty obvious, that if I took 3x plus 2, right, and I multiplied it by 3, I'd get 9x plus 6. Right? Just thinking about the distributive property, right? 3 times 3 is 9, 3 times 2 is 6. So if 3x plus 2 is equal to 7, then 9x plus 6 would have to be equal to 21. All right? No matter what that value of x is, and by the way, the value of x would be 5/3, it would not be fun. I would not want to have to deal with that in here. But if I did take 5/3 and I put it into 9x plus 6, I'd find that the result would be 21. Now, thinking a little bit about 3x plus 5, again, let's do this together, right? How does 3x plus 5 compare to 3x plus 2? Well, let's try to get 3x plus 2 involved with 3x plus 5, right? Here we've got that associative property going again. 3x plus 5 is going to be 3x plus 2 plus 3, right? All I'm doing is changing a 5 into a 2 plus 3. Definitely 5 is equal to 2 plus 3. So I can then rewrite this as 3x plus 2 plus 3. We know that 3x plus 2 is equal to 7 because they've told us that. And 7 plus 3 is equal to 10. All right. The key here is I'm viewing 3x plus 2 as a single entity, right? And I'm trying to then relate some other quantity I have, like 3x plus 5 or 9x plus 2, to that single quantity. These can get pretty challenging, all right? But they are great practice because they force you to think about things like the distributive property, factoring, the associative property, not so much the commutative property, although we could see that come out a little bit in the next exercise. So let's just do a bunch of these. Let's take a look at exercise number 4. The expression 2x plus 10 has a value of 4 for some value of x. Again, don't solve for it. Do mindful manipulations on each of the following to find the values of these expressions for the same value of x. All right, let's do the first two together and then have you play around with the rest of them on your own. All right, the first expression I'm looking at is 8x plus 40, and I want to get 2x plus 10 involved. All right, well, you might think to yourself, oh, I'll take 8x plus 40 and I'll factor out a GCF, right? But the problem is if I factored an 8 out of this, I'd have 8 times the quantity x plus 5. 8 times the quantity x plus 5. I don't want to get x plus 5 involved. I want to get 2x plus 10 involved. Now, obviously, right, 8x is just 4 times 2x. And in fact, if I took 8x plus 40, actually, let me move this and just erase this. If I do 8x plus 40, and let's say wrote it as 4 times something, here's my 2x plus 10, right? 8x plus 40 is simply the same as 4 times 2x plus 10. Now I know 2x plus 10 is equal to 4, so that's just going to be 4 times 4, which is equal to 16. All right? That's it. Nice little squeaky board I got going on today. So in this case, what we're doing is we're thinking about some kind of product. On the other hand, in letter B, where I have 2x plus 13 compared to 2x plus 10, right? Notice that those two x's, those pair of 2x's are the same. So in this situation, I can say something like this. 2x plus 13 is equal to 2x plus 10 plus 3. Right? That's just 3 more than my 2x plus 10. So that's just going to be 4 plus 3, and we're going to have 7. All right, now let's do one that we haven't seen before. So we saw like these kind of two in our first two exercises. But 2x plus 6 compared to 2x plus 10. right? Notice here, the 6 is smaller than the 10, all right? So in this case, right, we want to kind of think about subtraction. 2x plus 6 must be 2x plus 10, but then minus 4, right? That 6 can be thought of as equivalent to 10 minus 4, in which case that's just 2x plus 10 as a single entity, minus 4. And 2x plus 10 we were told was equal to 4, so 4 minus 4 is equal to 0. All right, and as always, we're going to pull a common Kirk trick here. I did the 3 easy ones with you. What I'd like you to do is pause the video now and see if you can work out D, E, and F. Go ahead. All right, remember what we know. 2x plus 10 is equal to 4. Maybe I'll write that right here. 2x plus 10 is equal to 4. I want to kind of keep this in my mind, all right? So then I look at x plus 5. Now, how does x plus 5, how does that relate to 2x plus 10? Well, x is 1/2 of 2, and 5 is 1/2 of 10. So x plus 5 is going to be 2x plus 10, all divided by 2. Remember, division distributes, so that's going to be 4 divided by 2, and that's just going to be 2. So if you got 2 on there, you're getting there, right? Now letter E might have been very simple. Here we have negative 2x minus 10 compared to positive 2x plus 10. Well, negative 2x minus 10 is simply the opposite, or better yet, 2x plus 10 times negative 1. Right? This is the same as negative 1 times 2x plus 10. That's going to be negative 1 times 4, and that's going to be negative 4. Now, maybe the hardest of them all, 2x minus 10. How does 2x minus 10 compare to 2x plus 10? Well, again, the 2x's are the same, but that plus 10, right? That's the tricky thing compared to the minus 10. If you think about it, right, again, we want to get that plus 10 involved. Well, how would I have to modify this in order to get that? I'd have to subtract 20, right? So in other words, in order to get the negative in 10 involved, I'd have to have a positive 10 minus 20, which would then be 4 minus 20, which would be negative 16. All right, and that one again is a little bit trickier because you really have to extend. It's actually very similar to letter C, right? Where I had to start with 2x plus 10 and I had to decrease by 4 to get to 2x plus 6. Here I start off with 2x plus 10 and I have to decrease by 20 to get all the way down to 2x minus 10. Now the final one, and this is the most challenging one. All right, remember I've got 2x plus 10 is equal to 4, and now I have to think of 6x plus 35. Okay, so this one's a little bit trickier to manipulate. I want you to pause the video now, and I want you to play around with 6x plus 35 and try to get 2x plus 10 involved. We have to get this expression involved. If we don't, then there'll be no way to really figure out the value of that expression. So play around with it a little bit. All right, I always want to encourage you in math to play around with the algebra. Always have scrap paper available, always have extra paper. Don't think that you've always got to kind of nail it right at the beginning. Now, one thing I can notice, right, is that 6x is 3 times 2x. All right, 6x is 3 times 2x. That should be pretty automatic for us now. So maybe it's just, all I have to do is multiply this by 3. But if I take 3 and I multiply it by 2x plus 10, maybe this is the thing that we're sort of doing on the side of our paper, we would get 6x plus 30, right? And 6x plus 30 is close, right? It's close to 6x plus 35, but it's not quite there. But yet I could get 6x plus 30 involved, right? In fact, I could say 6x plus 35 is 6x plus 30 plus 5. In which case, I can now say I've got 2 or 3, sorry, times 2x plus 10 plus 5. This is what my 4 is equal to. So I'll get 3 times 4 plus 5. That's 12 plus 5, and that's 17. In all the other situations, all I ever had to do to my original expression 2x plus 10 was a single operation. I multiplied it, I divided it, I added to it, I subtracted to it, somehow to get, right, this thing involved. In this case, I actually had to do 2 manipulations to make it happen. But I can get kind of close by doing that product, and then all I have to do is do a little bit of addition or subtraction to get the rest of the way. All right, let's do one more problem. Let's take a look at exercise number 5. If the expression 3x minus 4 has a value of negative 3 for some value of x, then what is the value of the expression 3x plus 4 squared plus 6x minus 8 for the same value of x? Show the calculations that lead to your choice below. All right, so I'd like you to play around with this a little bit. See if you can get the expression 3x minus 4 involved in this more complicated expression. Psst, it's already there right there. But you're going to have to get it involved more than once because that 6x minus 8 is still a little bit problematic. Pause the video now and see what you can do. All right, well, let me write that expression out a little bit larger so that we really have got it on the screen, right? 3x minus 4 squared plus 6x minus 8. And right, what we know is that 3x minus 4 is equal to negative 3. So that's easy enough here, right? This is just going to be equal to negative 3. All right, that's no real problem. But this is a little bit trickier because it's not 3x minus 4. On the other hand, it is 2 times 3x minus 4. So at the end of the day, I've got negative 3 quantity squared plus 2 times negative 3. Negative 3 times negative 3 is 9. 2 times negative 3 is negative 6. And 9 minus 6 is positive 3. All right. And again, it's important for us to be able to look at 3x minus 4 squared and realize, well, if 3x minus 4 is negative 3, then 3x minus 4 squared is negative 3 squared. A little bit trickier when we have to think about the distributive property here in terms of getting that 3x minus 4 involved. All right, let's summarize what's going on here. So this is a very different lesson. You know, oftentimes in lessons we will be teaching you procedures for how to solve equations or graph lines or what have you. In this lesson, we really wanted you to be using things like the distributive property and the associative property to try to manipulate expressions in mindful ways, right? In ways that might get you somewhere, right? And in order to do so, we kind of created these problems where we told you what an expression was equal to and then had you manipulate another expression in mindful ways to get that original expression involved. This is really, really good in terms of a skill set that you want to have before you move on to further lessons in algebra. And we will see it in the future. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.